Okay, sweet. We should be recording. Um, so this week, right, is product rule and quotient rule and power rule and all these sorts of things. Now, I know that some of you know the chain rule. You can do this with the chain rule. Use that to check your answer, but you also should be able to do it without the chain rule, right? So make sure that you are comfortable with what would you do in this sort of situation if you didn't have the chain rule available to you. All right, Olis, that's definitely one option. So you can do a full expansion. That would be a good way of doing it. There's also a product rule way of doing it. Absolutely. Chain rule is next week, Sarah. Oh, that's not good.
I'm surprised that one is that high, Tyler.
I know, I am too. But there will be an important learning lesson here for many of the class.
And that's really what matters.
That is what matters. Let's learn now by making silly mistakes so we don't make silly mistakes later.
Luke, someone was asking for book recommendations.
All right, everyone. So we're at 55% voted, but I don't think this one's too bad. So I'll give you about 45 seconds here, see if we can wrap it up. Now you can imagine this probably isn't the sort of question you would get on a test per se, but let's just get warmed up a little bit and make sure that we're all okay. All righty. So 10 seconds, try and get those in. Last minute votes in. And done. All right, let's take a look at the results. Okay, this is a little concerning that we are mostly split between B and D. This is, it's a calculation problem. I think some people, some people are not, some people are cheating and not cheating correctly, and not cheating, but using something that they're not supposed to use and are not using that correctly. All right,
I
I'm
mean,
trying
they
to.
got like the first bit of it.
Yeah, they got part of it. Yeah, nobody voted for A. Thank goodness. That's good. But I think we are going to go to breakout rooms so you guys can yell at each other. Not actual cheating.
I don't think
Just
that big.
there we go. There's breakout rooms. It's not actual cheating, right? It's people who are using a technique that they thought that they were allowed to use, used it incorrectly, and now have the wrong answer. So I don't imagine this is going to
Can't
be
say I've
the.
ever experienced anyone yell in breakout rooms.
Yes. Maybe not. I mean, we just can't be in all the breakout rooms at the same time. So maybe it's happening.
That is true. I feel it's much more likely that it'll be dead silent, though.
Yes, that's true. It probably does tend to one extreme more than the other. I have a suspicion, though, in the ones that do talk, there's going to be lots of, oh, yes, damn, that was a silly mistake. Though I guess we will see. All right. How long have we been gone for? I'll give it another 30 seconds or so. 5 minutes? That doesn't seem right. Hasn't been 5 minutes yet. I think it's been like 2 minutes. Yeah. I'll give him another minute or so. We'll come back. Because everyone's in breakout rooms, Daniel. Which, because you came a little late, you don't have one, but it's not worth going, I think, right now, because we'll come back. No, that's too bad. Too bad. Well, we'll see how people vote this time. But maybe you have to be the person who gets it started. All right, you got to go in there and crush it. All right, no. But see, then you're part of the, right? You're part of the problem because you don't want to talk, but nobody else wants to talk either. Like I said, it is a little bit easier in person because I just make you guys. But yeah, in person it's a little bit easier because you all just, again, we tend to form groups, and it's a little bit easier when you're like sitting beside the person, like, yo, what'd you do? Okay, a couple people. All right. We'll see. You know, honestly, I think it's kind of hit and miss at this point. We have no idea.
Yeah, it really could go either way, but I do hope it isn't.
Yeah, I hope it's not too, but we will see. Like, I can tell you guys from what I know, the answer is we have no idea.
That sounds about right.
Yeah, we're kind of keeping things completely open so that we can go either way, and we'll see. All right, so we're at 72% of the vote. Let's do 30 more seconds. Get your votes in.
I mean, university life is more enjoyable after high school in a regular setting.
Mm-hmm. I mean, I think it probably would be anyway. I mean, traditionally, a lot of the university life also involves a great deal more independence, right? Yeah, and so that's kind of a thing, is that especially for, you know, a lot of people who might still be living at home, it's very kind of similar, right? 18, 28, and then 26. Did it do that? That's weird if that did happen. We just traveled a little bit back in time, maybe. Okay, so poll results, this time 78% on D, and absolutely that is correct. So good job. A couple of you are still on B. Now, no, Linux is far more reliable. Neri, you'll have to provide evidence. You'll have to get the video afterwards and show us where this actually happened. Okay, so for those of you who said B, you know, again, I think that you're cheating a little bit. Cheating in the sense that, again, you're using the chain rule, even though we don't know the chain rule, but you haven't applied the chain rule correctly, right? So you have to just be a little bit careful about this. So I'm going to show you what we can do. All right, so let's try it. So again, for those of you who do know the chain rule, I'll maybe do it very quickly at the end. But right now, the first thing we're going to do is we're going to expand this out. So we have g of x is what? It's 2x plus 1 all cubed, okay? And so if you want, you can expand that out, and I think you get, what is it, 8x cubed plus 12x squared, plus 6x plus 1? Is that right? I worked it out. Yeah, that looks right to me. And now at this point, we can just differentiate, right, using our power rule. So g prime of x is 24x squared plus 24x plus 6. And boom, that is exactly what D is, right? So that's it. That's all you have to do, and you're finished. Now, if you didn't like doing that expansion, I think there's actually probably a slightly easier way to get at this, which is to say using the product rule. Okay, so this here uses the power rule, but we had to actually expand it out. So instead, let's use the product rule. So let's write g of x as 2x plus 1 times 2x plus 1 times 2x plus 1. Now, most of the time, we are kind of interested in working with the products of two functions. And here we have the product of three functions. So let me ask you, does anyone know, and I think this is covered in the notes, but does anyone, but I don't think I did it in a video. Does anyone know if you have the product of three functions, how does the product rule change? Right? So maybe let's just kind of do this as an aside here. So if we're trying to differentiate f times g times h, what do we get? You know what? I'm going to rewrite that on a different level just because it's going to be a little bit long. So d dx. And you know what? I'm not going to write the of x's just because it's unnecessary. So you guys should be able to put this in the chat. Don't worry about the of x's. You can just write like f prime, g prime, whatever. F prime, g h. F, beautiful. Kushi, absolutely. So f prime, g h plus f g prime h plus f g h prime. Okay, and this isn't too bad to do. And Abdur Mansour, I missed yours. Yes, yours is absolutely correct as well. You kind of like put the derivatives in the opposite order, but yeah, it works out. So exactly. Now, again, the notes shows you how to actually figure this out. Like if you don't know how to do this, or you don't know how to generalize it to four functions or whatever the case may be, but you'll notice that there's this nice pattern where you kind of like just push the derivative down the line, right? So we write down fgh and we put the derivative on the first of those functions. We write it out again, put the derivative on the second function. We write it out again, put the derivative on the third. And you can imagine that if you had a product of four functions, you would do exactly the same thing, right? You would push it down the line like that. So Kushi kind of starts at the left and pushes it down to the right, and Abdul Rahman starts on the right and pushes it to the left. It doesn't matter because, of course, doesn't matter the order that you add things. So knowing that, now we could apply the product rule to this function, but f and g and h are all exactly the same function, right? They're all 2x plus 1. So if we product rule g of x, so we'll get the derivative of the first function, right, which is just 2 times g times h. And then we will do the derivative of the second function, right? That's 2 times f and h. And then we'll do the derivative of the third function, which is 2 times the other two functions. And in total, that gives us 6 times 2x plus 1 squared. And if you were to expand that out, you would get 24x squared plus 24x plus 6. Okay, which would be the same answer. Also, for those of you who have done B, hopefully you can see how this is different than your answer, right? So the B answer that some people answered, they said 3 times 2x plus 1 squared, and it's not 3, it's 6 times 2x plus 1. Okay, how did I get 2 times 2x plus 1? Okay, right. So so what we're going to do here is the f prime g h term. Okay, so f and x, f and g and h are all the same function, right? They're all 2x plus 1. So f prime is 2, g is 2x plus 1, and h is also 2x plus 1, right? So that's 2 times 2x plus 1 squared. So does that make sense, Caleb? Okay, cool. Right? And hopefully you can see that because they're all the exact same function, that every single one of those terms, like if you do f g prime h, you get exactly the same answer, right? And that happens precisely because all three of the functions are identical. We show how it kind of like obviously depends on the question. I think Asan kind of mentioned something like this on Piazza, which is basically, you're allowed to use calculators. And so just like in the linear algebra portion, if you say, listen, I computed this derivative using Wolfram Alpha or Symbolab or whatever, as a general, that's going to be fine, but you probably want to include a word there saying it, right? But that being said, again, remember, you still have to know these rules because there's going to be times and opportunities where we can ask you a question where you won't have a choice, right? You'll have to apply these rules. And actually, I can give you a question of like that. Let's go straight there then. Here. Okay, so I could give you a question like this, where again, you're going to have to apply these rules. Probably no amount of Wolfram Alpha or Symbol Lab is going to save you. That's actually a lie. It is possible to actually have Wolfram Alpha do this for you if you know how to do it, but you'd have to learn a little bit about how to tell Wolfram Alpha to do stuff. Can we just simply expand that? Yep, Nair. I think that's the first thing that I did. Right, that was my very first solution, was to expand that and differentiate. But absolutely, that is a valid way that you can answer this question, and you'll get the right answer. Yeah, it's the thing you have to kind of worry about, and the whole reason that we'll eventually do the chain rule is like if I make this 2x plus 1 to the 2002, right, or something like just a crazy big exponent, where you still want to be able to differentiate that, but expanding it out is probably going to be a little bit nasty. So that's the direction that we're headed. And for those of you who said the answer was B in that last question, I think it's because you were using the chain rule. And if you don't know what the chain rule is, don't worry about it. But for those of you who said B, you forgot to differentiate the inside, right? You forgot to differentiate the 2x plus 1 term, which gives you the extra 2, which you need to get the right answer.
You much of a Marvel fan, Tyler?
No, probably not.
More of a Star Wars guy, right?
I mean, I probably know more Star Wars than even I'm willing to admit. But
I've literally seen you wear a Chewbacca shirt.
Sure. Slothbaka shirt. Yeah. Like, in the sense that I'm fairly familiar with a lot of the lore. I think even a lot of the background lore that a lot of people don't know. On the other hand, like, especially with the last, with 7, 8, and 9, I'm just so disillusioned with everything.
Okay, ignoring that, and what about Mando, though?
It's okay. I enjoy it. I don't know. It's in the same sense that like Rogue One was enjoyable, but wasn't really a Star Wars film. Like I think Rogue One was a good movie, but it's not a Star Wars movie. It takes place in the same universe, but
so you only count the numbered entries.
No, it's that if the whole, so much of the premise is around the Force and Jedi, and if you don't have those as kind of integral components, then you're just taking place in the same universe, but it's not really a Star Wars movie, right? Like it doesn't matter.
I mean, you still had stuff with the Force in Rogue One, but it was more centered on the rebellion, which is kind of an important part for the original trilogy.
Then go back to 10,000 years and go talk about the Old Republic, because there's lots of like super cool stuff there, and the fall of the Sith originally, right?
Well,
but at least you actually had more Jedi.
If they went back to the fall of the Sith and the introduction of the Rule of Two.
Yeah, it'd be awesome.
Or even if they did stuff with earlier Darth Sidious, like when he was under Darth Plagueis or something like that.
Yeah. Yeah, the original movies are great. But yeah, at the end of the day, same sort of thing. Like I don't know if any of you have seen like the original cut of A New Hope. It was also garbage. It was just quite terrible. But also 30 seconds, and then we'll wrap this up. So get your votes in.
I don't know. The thing that really does it for me is that very distinct scream that they make in the Star Wars movies when they get hit by a blaster.
The Wilhelm scream.
Yeah. Yep.
Sure. Yeah. And you're nice being able to pull out Wilhelm too. You had to type it. I just had to say it out loud. Okay, let's see where we got. All right, we're leaning a little bit towards B, but again, lots of people on A. This shouldn't. Okay, I'm gonna give you just like 2 minutes in the room because this shouldn't take long, I think, to sort out. For those of you who don't have a room, I'm gonna throw you in a room right now. I feel like I have to keep putting people in room 4 because they keep leaving. Nobody wants to be in room 4.
I'll go to room 4.
Okay. And 30 seconds, and I'll start bringing people back. Okay, so does that give you the wrong answer? 3x 12. Ah, yes. Yes. Good call, Jordan. Okay, we've got 72% of the vote in. I'm going to give you 20 seconds or so here. Yeah, I always wonder, it must be the same thing like when you're watching a video of this, which I guess is like anytime you watch a streamer where they're like responding to questions and you just have no idea what the questions are. So I get also lots of direct messages to people which I'm trying to answer. But of course, the rest of you can't see it. So it must be just mysterious. Okay, awesome. Coming in. So we do have consensus on B. B is the correct answer. Phenomenal. Let's see why. Let's see if we can't shed some light on it. And Jordan, good job kind of figuring out what some of the people who said A might have been thinking. So let's recall what the question is. All right, so we've got h of x is x cubed g of x. And we've got two pieces of information. We know that g of 2 is 1/2 and g prime of 2 is -1. And the question is, what is h prime of 2, right? Okay. So we see this is a product of two functions. So that kind of screams that we're going to have to use the product rule, right? And so this is what I was saying. The reason why we kind of jumped to this question is because, we wanted to very much show that you still have to know the rules, right? Even if you can use a calculator, you don't have a choice. Sometimes you got to do it. Okay. So I'm writing it out kind of long form, just so that everyone can kind of see the product rule at work, right? It's the derivative of the first times the second plus the derivative of the second times the first. And don't forget, this is like the defining property of what differentiation is, that it doesn't nicely, you don't have the derivative of f times g is f prime times g prime. You have this weird product rule that you have to use. Okay, and we can solve this thing. That's just going to be the power rule, right? So we're going to get 3x squared g of x. And then, well, there's nothing we can really do over here other than just write g prime of x. And now we're going to plug in 2. So h prime of 2 is 3. Oh, that's not a 3. That's a 2. Okay, 3 times 2 squared times g of 2 plus 2 cubed g prime of 2. So that's going to be 3 times 4, so that's 12. G of 2 is a half. 2 cubed is 8. G of negative 2, or g prime of 2 is negative 1. So we're going to get 6 minus 8, which is negative 2, right? Negative 2 was B, so that is our correct answer. Okay, so yeah, and that's another thing too. I want to emphasize, some people, I think, if you get, the hope is that you practice enough that you can do it in your head, right? If I see the derivative of x cubed g prime of x, right, I can just go straight to 3x squared, g of x. I can just go straight to the derivative, right? But there's no expectation that you should be able to do that. And I really want to emphasize that where necessary, break it into smaller steps, right? Like, you're not going to get any bonus points for, how quickly or pithy or short your answer is. Take the time if you're not certain what to do and make sure you step it out. And yeah, what's really going to happen, as Jordan kind of brings up with the multivariate differentiation, is that when you have like x's and y's and z's potentially hanging around, and you have to differentiate, even if you're good and can do single variable differentiation in your head, the multivariate stuff can actually start to throw you off because you can't track that much stuff in your head, right? So break it into smaller parts. It'll save yourself a lot of headache and nightmare later. Okay, so are there any questions about that? Don't forget, right? You got to add here, right? This is so important, right? That the derivative of the product is f prime g plus fg prime, right? So hopefully that's okay. All right, let's maybe make our brains hurt a little bit. All right, here you go. It might look a little bit nasty. It's not too bad though. You just got to go through it, and you got to be comfortable doing it. Right? I think there's a lot of opportunity here to make an arithmetic mistake. So make sure you go through it slowly and are just really comfortable with what's going on. And this also might be a really good place to try and break this into chunks, right? Some people will be able to do it all at once, right? We'll just be able to like write down the answer. That's totally cool. If you can't do that, break it into chunks. Is the derivative e to the x e to the x? Yes. Yes, it is. Yeah, that will help now. Just smashed my pen on my tooth. Okay, so we're coming up on the 5-minute mark. And we've only got about 45% of the votes here. So I'm going to give you guys another 30 seconds or so. See if you can get the votes in. I don't think this is going to be breakout room useful for this one, just because there's a fair amount of work involved in trying to pinpoint where any one person made a mistake is going to be a nightmare. Okay, 10 seconds. Yes. Yeah. Okay. So pretty evenly split with a plurality in C and then D and then B, and then nobody seems to like A. Maybe that's a meta thing because A just doesn't look like the rest of them. Okay. So remember that split, okay? Everyone thought that C and then D and then B. So B was kind of like the least favorite. So, all right, let's see this. All right, now there are a couple of ways that you could attack this. Again, if you know the chain rule, you can do it that way, but of course we don't. So that's not how we're gonna do it. So we've got f of x is equal to x plus 1 divided by x e to the x, okay? Now, quotient rule, as Haysam has kind of written actually out in the chat, right? So it's the derivative here, u is the numerator, v is the denominator. So when we differentiate, we're going to have, and I still say this to myself when I actually do this computation, right? So I have the derivative of the top times the bottom minus the derivative of the bottom times the top, all divided by the bottom squared, right? Okay, so I haven't actually done any computation yet. All I've done is write out what the quotient rule is and broken it into its corresponding parts. Now, a lot of this is not too bad, right? So this first derivative here, this thing, right, this is just 1. But we're going to have to compute this, right? Because I don't know what it is. So let's compute that kind of separately. So d dx of x e to the x. So for this one, I'm going to have to use the product rule, right? And again, if you can do it in your head, phenomenal. But if you can't, just write it out. Derivative of the first times the second plus derivative of the second times the first. All right. If we do that, we're going to get, so this is again just 1. The first bracket is 1. So e to the x plus x e to the x. And if we want, we can just do a little bit of simplification there, right? E to the x times x plus 1, right? So that's going to go into there. So let's rewrite this out. Oops. So we get f prime of x. And again, remember we said that this first bracket, that's just 1. So we're going to get x e to the x minus e to the x. Maybe let me put that in square brackets. It doesn't matter, but I think it's just a little bit easier to read. Times x plus 1 divided by x squared e to the 2x. Okay, so that there, that's me actually just figuring out, squaring that entire denominator, but I distributed the square. So I get x squared e to the x all squared, but when you square e to the x, you just get e to the 2x. Okay, now it's just mostly algebra, but there's plenty of opportunity. So Kayla, factor in e to the x out of both terms, right? Because everything's got an e to the x out. So when you factor in e to the x out of the first thing, you get a 1. And when you factor it out of the second thing, you get an x. So, you could write it as e to the x times 1 plus x if you wanted to. Or alternatively, if you want, expand out the right-hand side. And hopefully you'll be able to convince yourself that it is the left-hand side. Okay? So hopefully that makes sense. Now I've got some algebra to do here. Yes, the derivative of e to the x is e to the x. So we're going to expand this out. So we're going to get e to the x squared plus 2x plus 1. Okay, so that's me expanding out this x plus 1 times x plus 1. X squared e to the 2x. And actually, if I want, I can factor an e to the x out of everything too, right? Maybe let me write that like this. Times x minus x squared plus 2x. There's a bunch of different ways you could do this, right? This is just kind of how I want to do it. And we see there's a little bit of simplification. So we're going to get 1 over e to the x times negative x squared minus x minus 1 divided by x squared, or negative x squared plus x plus 1 divided by x squared. Oops. Right? And that was B. Okay, so B was the actually second least popular of those, of the poll answers, right? It's, again, there's plenty of opportunity here to make mistakes. I think C, people who would have guessed C probably had the right answer, but just kind of forgot this minus sign right here, right? That this is going to negate everything there. So you get that cancellation, but you can't forget pretty much everything is negative because of that. D is very tempting if you kind of forget, and maybe you didn't even notice it in D, but you have that e to the 2x in the denominator, and that's no good because we're actually going to cancel out one of the e to the x's here. So we only get 1 over e to the x. We're not going to get 1 over e to the 2x. Okay, does that make sense? Are there any questions on that? Can I repeat how I factored the 1 over e to the x out? Sure. So basically, I see, if you want, actually, let me just kind of restart from here. If we want, we can just expand this out a little bit more. So x e to the x minus, x squared e to the x minus 2x e to the x minus e to the x, right? So that's kind of me expanding out that term. And then I see, oh, look, here is a x e to the x, and here's a 2x e to the x. So those are going to cancel each other out pretty nicely. So I'm going to get negative x squared e to the x minus x e to the x. And you'll notice everything's got an e to the x in it, right? Oops, that should be e to the 2x. So since everything has an e to the x in it, I'm just going to pull that out. Right? But if we want to go back up here to this top line, basically there's an e to the x here, and there's an e to the x here. So I'm going to factor that out of both of the parts, and that's how I'm going to, get my answer there. Okay, in the final answer, when you factor out the -1, would the denominator become negative? So there's... It depends on what you mean by that. Almost like when you... because I factor the negative out of the numerator, I can just kind of put it in front of everything. I could put it into the denominator if I want, but it doesn't necessarily, Sarah, that's the bottom. So there's nothing, unless you're saying like you want to be able to see more up top. But when you factor out that negative sign, like it doesn't necessarily change the denominator, right? It's like saying 2, what do I want? So let's say if I had x over x plus 1 divided by x plus 2, if I factor that x out, it doesn't like do anything to the denominator, right? Like you can just kind of like pull it out. Narrative, it should be it should be up pretty soon after our lecture. Yeah, okay, cool. And Sarah, did you get what you needed? Because yeah, there's just nothing more down beneath. Okay, cool. So is everyone all right with that? Do you see how that works?
Prof, I was just wondering how did e to the power of 2x become e to the power of x?
Sure. So here, So you have e to the x divided by, there's a couple ways you can do this. So this is e to the x times e to the x, right? Because it was e to the x squared. So if you do this cancellation, you would get 1 over e to the x. Or you could say e to the x divided by e to the 2x is e to the x times e to the negative 2x. And when you have a common base, you would add their exponents. Right? So there's a bunch of ways that you could do that, but they all kind of work out to give you 1 over e to the x. So does that make sense? Does that clarify?
That makes sense now.
Okay.
Thank you so much.
No problem. Okay, everyone else good? All right. Let me hurt your brain a little bit because you thought you probably weren't going to have to do factorials anymore. Yeah, and Young, exactly, you're going to differentiate 21 times. Mm-hmm. Yeah, I mean, if you really want to do it 21 times, you absolutely can. But, you could imagine that I'd ask you to do this 2,000 times. And then if you want to waste a good chunk of your exam actually computing the 2,000th derivative, but try computing, exactly. Try computing, the second derivative, the third derivative, the fourth derivative. See if you can see a pattern and use that in order to figure out what the 21st derivative should be, right? And there's a big, kind of meta contextually, you can look at these questions and you can be like, obviously, no, it's just D. You can look at these questions and you can be like, obviously, he doesn't actually want me to differentiate it 21 times, right? Like there's a reason why that number is so big that, when the numbers are like this, it says that the numbers actually aren't the important part, right? We kind of want you more to see if you can find the pattern and figure it out from there. I mean, maybe like there, it's not a Durman. There is something to be said for being able to meta multiple choice questions. And that's totally okay. And that's a decent test skill as well. Though in this case, that it's probably not going to help you. So you probably want to see if you can figure it out without using the fact that it's multiple choice, right? Like, even if you can tell which one it has to be for multiple choice, then go through and convince yourself that, yes, that answer does make sense. Not just because you managed to eliminate, the other three. Mm-hmm, mm-hmm, mm-hmm.
When did you stop doing multiple choice questions on the 133 test anyways?
When we went remote.
That makes sense. But then again, I guess even in my year, it was kind of a combination of short answer and multiple choice for the first bit.
Yeah, your year, I think it was more just like, it wasn't necessarily multiple choice, if I recall correctly. We were still doing the like, here are 5 questions, just put in the answer. Sometimes there were multiple choice, but generally it was just like,
yeah, it was usually just like short answer, either you get the full mark or nothing.
Yeah.
The only one I explicitly remember being multiple choice was for improper integrals and what value of p will make it converge or diverge or something like that.
Yeah, I think I vaguely remember that question. No, Sarah, I mean, like, multiple choice is very dangerous in a non-proctored exam, right? And, you know, we've caught a couple of people academic integrity-wise just because they're not multiple choice, but when things are multiple choice, you just have no way of catching people, right? Like, when you guys can start a group chat, just share all the answers, and there'd be nothing we could do. And if I had to go to my department head and be like, yeah, man, like, they all got 95% on the final exam, then that would not, right? Like, there would be hell to pay. And not because, like, I would, like I said, I would love if I legitimately thought we had a fair exam and you guys got 95% on it, I would just be ecstatic. And I've told you, I would fight for that. I'd be like, listen, I gave them a good exam and they just crushed it. But you have to imagine, especially in a math class, if everyone does very, very well, especially in like a first year math class that isn't necessarily for mathematicians. And again, that's not to put you down. It's just like most of you don't really care about math, and many of you aren't very confident. And so if everyone got 95%, there'd be some red flags there, right? So Sarah, you know, what happens is, yeah, Jordan, I think yours was the only final exam that was ever adjusted. But so we always make the final exam the easiest of all the tests. Now, what that doesn't necessarily mean that students do the best. And the reason for that in part is because it's cumulative, right? Exactly. Way more content. And, you know, if I asked you guys a financial math question right now, how confident that you would be that you could answer it, right? And exactly. So, you know, just we try and make it as easy as possible precisely because we understand that that is a problem and that we are specifically trying to kind of account for that. But yeah. Yeah, okay. So like, let's say I give you a principal. Let's say you have exactly 4-week months, and I give you a principal P at the beginning of the first week and the third week, and a principal Q at the beginning of the second and fourth week. And a compounding period of R, S, T, and U. So R in the first week, S in the second week, T in the third week, U in the fourth week. What is the value of this account after 52 weeks? Sarah, there's actually a reason for that those bonus quizzes were a thing. That was actually a hard question. Would have been a hard question when you guys were in your prime. But right. Well, it's okay. It'll be on recording. You guys will be able to go back and listen to me re-say it and see if you can do it, right? No, but it's in the recording, right? So once the video is posted, you'll be able to go back and use this as a practice question when you guys are studying for the final. Okay, we've got 80% of the vote here. Let's what we see. D, this is phenomenal, guys. I'm actually a little bit surprised because I thought this was the hardest of the like 4 questions that we did, and you guys just came out and, you know, pretty much got it on your first try. So I'm very happy with this. For those of you who didn't get it, let's kind of talk about what it is and why. Let's see if we can sort it out. Okay, so the key, bonus for good behavior. So the key is to just do a couple of derivatives and see if you can find a pattern, right? So we've got f of x is x to the power of 2021. So let's just start computing derivatives and see what we get. So, you know, 2021 x to the 2020, right? That's what the power rule tells us. And I think I'll probably, you know, I'll do a couple, 3 or 4 derivatives so that we can see what the pattern is. X to the 2019, f triple prime of x. And anytime you guys are asked to do either general formulas or, 2020, thank you. Anytime you guys are asked to do either general formulas or higher derivatives, don't do the multiplication, right? And I think in this case, especially because you could see that there were factorials, that's a big hint. Don't like simplify, don't actually compute 2021 times 2020, right? Like that doesn't make a lot of sense. So times 2019 x to the 2018. And we'll do one more, but I think you guys can probably see what's going on here. 4 of x 2021 times 2020 times 2019 times 2018 x to the 2017. Okay. So it seems to be that it's the product of all the numbers from 2021 and down, however many times we've taken derivatives. So we're going to, if we take 4 derivatives, we're going to take 2021 and then multiply it by each of the numbers less than that 4 times because it was the 4th derivative, right? So now what we have to do is we have to figure out a way of writing that in terms of factorials. So let's kind of look at this thing in particular. Hopefully what you guys see is this is 2021 times 2020. This isn't obviously the only way to see it, but let me write it like this. So 2018 times 2017 factorial divided by 2017 factorial. Okay. And the reason why I've done it like this is just because I'm going to be able to simplify this numerator into 2021 factorial divided by 2017 factorial. Right? Do you guys see that that's the case? And you guys have seen this before, right? This is the permutation, right? N pick K is this thing, right? This is right 2021 pick 4. So you guys have seen this sort of thing before, right? This sort of number, probably not necessarily in this context, but you've seen this idea of doing that. The superscript next to the F, like this is a 4. Sorry, so F to the 4 of X. That one, this is just triple prime. I was writing a little bit messy, but Haley, does that answer it? The next line. Okay, cool. So what you guys hopefully see then, okay, so you guess the pattern. Probably if you were to write it out, F to the 5 of X is 2021 factorial divided by 2016 factorial, right? Times X, obviously, to the 2015, what do I want here? 2016, right? So you can probably guess F to the 21 factorial over 2000 factorial X to the 2000, right? And that was D. Okay, does that make sense? Does everyone kind of see it, right? It's just about kind of like figuring out what the pattern is. Now, obviously, we actually have this question prepared, but my next thing to you, and obviously lecture is done, so I'm not going to hold you guys any longer than you can go. It would be the sort of thing that, like, that's a great question, Olis. On a test, I would say, like, I would actually say this. I would say, like, it's almost like the writing assignment, right? You'd be like, let's compute a few derivatives and see if we can find a pattern. First derivative, second derivative, third derivative, fourth derivative. And then as a line, I would say, we noticed that, in each of these cases, it looks like 2021 factorial divided by blah factorial X to the blah. So F to the 21 is your final answer, right? And that would be totally okay. And Chiveng, yeah, that is exactly the question I want you guys to figure out. If I ask you now to find the kth derivative, could you do it, right? And then we actually have that question prepared. It is actually a poll question. If K is less than 2021, what is the answer, right? So if you generally took K derivatives of this function, what would your answer be? So F to the K of X. So here K is less than or equal to 2021 is equal to what? Okay. All right. Yes. Chifeng, I like yours. Olis, you're a little bit off. Look at F to the 4. F to the, where you might need some brackets in there, Olis. Yeah. Because I would read that as 2021 minus K factorial, right? And Carol, you're forgetting an X, but I think you have the right answer. And yeah, okay. Yeah, great. And Chifeng, what you wrote is actually now what Carol and Olis have both written, only you've written using NPK, which is totally fine. But absolutely, I think, a lot of you guys managed to get that. 2021 factorial divided by 2021 minus K factorial. So for chiefing for you, that is 2021 pick k, right? X to the 2021 minus k. Phenomenal, right? Yeah. Oh yeah, you wrote 20. Well, I knew what you meant, right? Because obviously you meant 2021, I think. But yeah, so you guys kind of see how you can nicely then see what the pattern is. So this is a question I think that when you first look at it, and try to be honest with yourself, when you first look at it, a lot of you are like, oh, damn, first of all, there's factorials in this thing, and then there are really big numbers. And I think a lot of people have an inclination to kind of like seize up here. But you can see if you just do a couple of them, you can start to see a pattern. And, if you see that pattern, we're not going to ask you to do any like big crazy proofs or anything. We're basically just going to ask you to do pattern identification. And so if you can see that pattern, you can generalize it to sort of any number, right? So that's the idea there. Okay. All right. So that takes care of the lecture, everyone. Good, good, good. For those of you who, again, kind of make sure that you review product and quotient rules if you haven't already, because they're a little bit tricky. And then do some higher order derivatives, because we're going to do some more higher order derivative questions. And I think I have some more kind of abstract quotient rule questions coming up too. So make sure that you practice those and are comfortable with them. And then other than that, I will see you all on Thursday. So have a good week. And don't forget assignment 7, right? Assignment 7 is due on Wednesday, and your writing assignment is due a long while from now, but don't leave that till last minute. And otherwise you're good. See you, everyone.
We have a hand raised, Tyler.
Okay, yeah. Well, whoever, I didn't get my pop-up for that. So whoever it was, just ask your question.
Oh, I think,
Yeah.
like a while ago, I asked you like if we need to explain like how we got the derivative. You said we could just use an online calculator, but we
Sure.
have to say like we used this online calculator to get the derivative. You said like we just can't write the derivative directly.
Yeah, I mean, you don't have to tell us specifically which one. You can just say by calculator, we got this. I think that's fine.
Yeah, because like usually I take really long to answer these problems just by finding the derivative. Do you know like which online calculator would be the most efficient to find derivatives as quick as possible?
I mean, I think everyone's going to have probably a different opinion here, but let me show you something. And you do have to be still a little bit careful with these sorts of questions, because here, let me, oops. So let's say you want to use something like Wolfram Alpha. The great thing about something like Wolfram Alpha is that you don't need to like know necessarily what the command is. You can say find the 21st derivative of x to the 2021. Hopefully this should work. And so you can see it just did it for you, right? Like you don't even need to know what the syntax is. The problem, of course, is that it actually computed what 2021 factorial divided by 2000 factorial is. So you can see that this is probably not going to help you in this case. But the benefit of Wolfram Alpha, I think, really over anything else, is you can describe to Wolfram Alpha what it is that you want to do, and it will do it for you, right? So I think that that's a pretty powerful thing. So you don't necessarily need to learn syntax, right? So for that reason, this might be, Wolfram Alpha might be a good thing to use.
Oh, I see. Jordan said symbol lab and derivative calculator.
Yeah, those are, use what you like. Like I said, the power for me from Wolfram Alpha is that, and I haven't used a lot of Symbol Lab, so I don't know if it kind of does something similar. Obviously, the benefit of something like Symbol Lab is that I think it gives you your steps. For Wolfram Alpha, you have to pay for their premium in order for it to give you the steps. But actually, I think many students that I've talked to say that it's definitely worthwhile, that it ends up being pretty cheap, and that Wolfram Alpha is pretty sweet. But yeah, the powerful and the flexibility of Wolfram Alpha is that you can just, right? Like I could, let's say I didn't want to write it as find the 21st derivative. What if I wrote it as d to the 21 divided by dx to the power of 21 x to the 2021, right? Like, and hopefully this works out. No, it's not going to. But sometimes it does know how to correctly interpret that. Let's see, maybe if I use, no, yeah, it doesn't seem to doesn't seem to like that. Anyway, the correct notation, I think, is this. Will that work? Close, except somehow it got Canadian dollars, but maybe X comma 21. Who knows? Okay, right. But anyway, I can just write it, right? Find the 21st derivative of, x e to the x. And this is going to be a nightmare. Oh, no, actually, this one's pretty good.
Oh, basically, it's a good type your question in word
Yeah,
form.
right? Like,
Yeah.
that's pretty sweet, I think.
All right. And Prof, a while ago for the first question, can you like go back to the first poll?
Okay, sure. I think, unfortunately, that I have closed my thing.
Your notes.
Yeah, let me just, winter week, 4 slides. You know what? I'm going to kill the recording because I don't think people need to see this.
Yeah.